Hello, hello, hello. My name is Dr. Tom Fernandez. Howdy. And I, I'm retired from teaching computer science. And among the different subjects I taught was artificial intelligence and also graphics programming. And so I'm working on a little project, and it's called Monet 25 for the famous artist Monet. And the goal of the art is to the goal of the program is to take photographs or other images and turn them into Impressionist art or something like Impressionist art. In any case, to take photographs and turn them into art. And so let's go ahead and get started. I'll show you how it works. It's a little bit complicated. I'm not going to. I've actually been working on making it a lot simpler, but let me just show you. First of all, there's two separate programs. There's what's called a circle generator, and it does some pre-processing on the image. And then there's an evolutionary program that will evolve art after the image has been pre-processed. And so let me just give you a quick show explanation of the workflow. So in this case, we start with the source image. And from the source image, we make what's called a circle list. Then from the circle list, we create a population because it's a genetic algorithm that has parameters that will sort of redraw the image from the circle list using different parameters. And then that evolves to try and optimize those parameters, where the goal is to make art that, that I like or that you might like, who knows. And then from there, it creates the actual artworks. So let me show you the beginning. So here, this is a picture of a cathedral in Mexico City. Now I have pre-processed it. There was a parking lot in front of it, so I just sort of scratched out the parking lot with a bunch of scribbles. That's this part down here at the bottom. And that's fine, because when it goes through the process of being turned into art, it won't be noticed that those squiggles are. It looks better than the parking lot. Okay, so that was that. If we go back here, I'll show you here's some artworks, and I'll show you the medium because and I want to go look for cathedral. I must have some already, yes. Okay, so here's cathedral, and here's a bunch of the artworks. I'll just expand the preview image. Wait. First I will sort by type. So I'll put all the JPEGs together. And then I'll just show you some of the artwork that was generated from that image. Okay, so here's some of the artworks. So I kind of like that one. That's kind of neat. And that one's interesting. And here's another one. And another one. And another one. And and finally another one. Okay, so these are artworks that were created from this photo of the cathedral in Mexico that I had pre-processed. I sort of scratched out the parking lot, leaving it a little rough, but that's okay because you can see in the artworks that that looks okay. Well, in fact, and it looks better than a bunch of cars in a parking lot. Okay, so that's where you start, and this is where you end. You end with different artworks, and actually, this is a medium resolution. If I go to a high resolution, and we look at the cathedral pictures. Okay, so this is high resolution. If you notice, the resolution is 16,000 by 10,800, and so if we zoom in on different parts of it, we can see that the image itself is made from geometric shapes and also other shapes. This one was made with geometric shapes, but it could also make it with spirals or circles or whatever the genetic algorithm decides that it wants to draw the picture with. This is at a resolution of 500. So if I go down to 100, so this is roughly what you would see if this was printed in high resolution and you came up close to the canvas and looked at it closely, you would see all these little triangles and images that the image is drawn from. Okay, so that's the program, that's what it does. However, I'm going to step you through the workflow, which involves going from it starts with the image itself. We saw that. From that, it makes a circle list, and it may be hard to so here's a circle list image. Now what the program has done is it's covered the original image with circles, and where the circles in the image, where there's little detail, it will cover the image with larger circles. Like we see up here in the sky, we see lots of large circles, and down here on the ground, because of I covered up all the parking lot, there's not much detail here, so it covered it with larger circles, not as large as the sky, but still larger. And then if we zoom in, we can see that as there's more detail, it covers the image with smaller and smaller circles. Okay, so this is actually stored in a file as a circle list, and you can see the areas that have detail have a lot of little circles, and the areas that have less detail are covered with bigger circles. So as in the sky and down here in the parking lot that I covered up. Okay, so after a circle list is generated, the next thing the program will generate is a population of individuals. So let me go up here. So these four subdirectories sort of indicate the workflow. So after we've got the circle list, we'll have a population. And if we go down here to cathedral, we can see that there's actually a couple populations. As the genetic algorithm evolves, you'll get more advanced populations. We can take a look at this one. This is the early population. And here's one of the images. Now that they're small because these are just sort of thumbnails that represent the different pictures. So this is one of the individuals that was generated to fill in the population, and there's probably a couple hundred of these because usually the population size I use is 200. So here's another one. Again, we'll zoom in a little bit. So this is another image of the cathedral. Now, this is the first population, so it's sort of like this is the primordial random soup from which the evolution begins. And I'll walk you through the whole process of running the program. Okay, so then after the population, then you get to the final artwork, and we've already looked at that. So I'm going to go ahead and jump in to the workflow, the actual workflow, so I can demonstrate how the program works. So there's really two programs. The first one's the circle generator, and then the second one is the evolution. We'll start with the circle generator. They're both written in C#. And we'll start up the Visual Studio by clicking on the solution file. And I'm still working on this code, so if it doesn't work perfect, that shouldn't be a surprise. Right now I'm in debug mode because I've been working on it, but I'll switch it to release so that it'll run a little bit faster. This is these are not fast programs, and the computer I'm running this on is about 7 years old, and I have to apologize. The program is complicated. I've tried to make efforts to make it simpler. I've taken off AutoGen just so I can show you how some of this works. I'll start by selecting an image, and I renamed Cathedral as Cathedral in Mexico City so I can show you how it works starting from scratch. So we've selected an image, and there are a bunch of parameters to the image, and these are the parameters. And I know this seems complicated, but I have a simplified way of doing it. The only real parameter that you need to fool around with is this one right here, which is called add square iterations, and it could range from like 0 to 5. If you make it a 0, there will be very few circles covering the image, and so it'll be a very blurry sort of impressionist view. And if you make it 4, if you make it 5, there could be a couple million, maybe 5 or 6 million circles covering the thing, and it sort of takes on photorealism. So if you range this parameter from 0, which would be very fuzzy, up to 8, which is going to be photorealistic, so you're sort of controlling how impressionist your pictures are going to be. And if I do it with a 1, then that's it's going to be pretty impressionist. It also runs a little faster with fewer circles. Now there are some other parameters that you might want to control. Like here I'm using 12 clusters. That's probably too much. I'll try 5 clusters. So after it creates the circles, it's going to cluster them by color, and I guess the easiest way is just to show you. So right now it's processing the image, and it's starting by doing statistical analysis of square areas within the circle and within the image, and now it switches to circle images, and now it's breaking it up into 5 clusters of colors circles. So this thing had 5 clustered circles, and you can see I can toggle whether or not the outline of the circles is being shown. So there you can see that, you know, there's bigger circles up in the sky where the variance of the color or the amount of detail within each circle is very low, and in areas with higher detail, there's less, there's smaller circles. Okay, now if I wanted to save this, I could click the little S button there, but I don't, because I want to show you how I've made this a little bit easier. If I turn on auto gen, then all I have to do is select an image, and I will select the same image again. So I will select Cathedral, Mexico City. I will open it, and now it'll make 4 different circle lists and automatically save them. So this is the first one. This is the more impressionist one, and it's created only about 120,000 circles, and now it's dividing those circles into their color clusters. And that's it. It's saved. Now it's going to do one that's going to be slightly less impressionist, a little more detail, a little more circles. This one is going to have, let's just see here. Okay, this one has almost 400,000 circles and shows a lot more detail. And again, it's going to break it into the color clusters, which are themselves kind of interesting. This is going to be the next program I play around with, is just fooling with the color clusters. Okay, now this one is going to take a little longer because it's going to create more circles and it's going to have more detail. And here we can see that there's well, it's only 231,000 circles so far, but it's not done. It's probably going to about quadruple that. We'll see in a second. Yes, okay, so this one has 1.1 million clusters. I'm sorry, 1.1 million circles. And again, we're going to see the color clusters that it divides out. So this is just sort of a pre-processing of the image before we can get started on really making the art. Now this one is going to be the slowest because this one is going to make, I'm guessing, somewhere between 3 and 4 million circles. And the images it's going to create are going to be interesting, but going to border on photorealism. Okay, so it's up to 600, around 650,000, but it's not done. And so now we'll see what's going to happen. Like I said, it's going to be slower because of the so many circles that it's going to be doing. I should point out I'm running this on a 7-year-old computer. It is Intel i7 with 6 cores and 12 threads. And later we're going to see that multi-threading is going to be a big part of this. Okay, so we ended up with 3.1 million circles, and the image is kind of photorealistic. It's the circles that are inside the cathedral are very detailed. In fact, they're not even being drawn, because if they were drawn, they would just leave like a black fuzz over the whole image. And now it's doing the color clustering, which the clusters by themselves are very interesting. They're almost like a sketch, like an artist's sketch of the cathedral. And now it's saving this, and it's saved, and that's done. So it's created 4 circle lists that range from having about 100,000 circles up to above 3 million circles. And that's it. And we're done with the circle generation part of the workflow. But the next step is, and I'll go ahead and close Visual Studio here, and we'll reopen it in the evolutionary part. Now, for the evolutionary part, this is where performance is really a big issue. And so I have not just the debug and release, but I also have a publish directory. And in the publish directory, I have an executable that is about 25% or between 25 and 30% faster than a release version. Okay, so this is the program that's going to do the evolution. And let me step you through the workflow process. First, we need to load a circle list, and we can go down here to Cathedral in Mexico City, and here we have 4 images that, and let's take a look at them. They'll represent the 4 levels. Okay, so this one is going to be more impressionistic. This one's a little less impressionistic. This one, and it's part of the title of this. It tells you how many circles there are. This was 1.1 million. This one was 3.1 million. So I'm going to use the one here with 381,000 circles, because one, it'll make the program run faster, and it'll create a more impressionist type art and not so photorealistic. So I'll go ahead and select this. And now the next thing I need, in order to have evolution, I need a population of individuals. So I will create a population of 200 individuals. And you'll see down here that there are 200 individuals that are unrendered. This bottom line here shows the status of all the individuals. And I also need to create some render threads. Now I'm going to go ahead and create, like, say 30 render threads. Now this is something I'm experimenting with. Maybe I should do less. Like I said, I only have 6 cores on this machine. But they are hyper-threaded. So there would be like 12. But the threads will actually have like a non-blocking weights within them. So I can give more threads and still maybe increase performance. So I'm going to try 50 threads. I'm experimenting with this. So I will try 50 threads. And so now there are 50 render threads. And you can see that the number of unrendered individuals is dropping, and the number of rendering threads is increasing, and we have 8 that are ready, and as soon as we get one more, we'll get to see these images. Now, the easiest way to do this is to just let all the images be rendered, and that'll take a little while. So let me pause the recording for just a second. Okay, so we've unpaused the recording, and now let me go back to the process. You can see that there's no longer any unrendered threads. However, there are no unrendered individuals, but there's 3 that are still being rendered, and so we'll wait for them to complete. Okay, so now all the images are rendered. There's 191 that are ready and 9 that are in selection. These are the 9 images that are in selection. And at this point, we're going to go ahead and click Save Population. So the population is saved. So we've saved this original population of art that was created from that circle list, which was created from the source image. And now we can go through a selection process, because we can just decide that, okay, so here we're trying to remove the worst ones. So I'll change it so that they're all selected. I'll do a select all. So you see the black line means that it's selected. And then I'll just take off the worst ones. So these are not that great. So that leaves these 4 that are kind of interesting. I think I'll get rid of that one too. So we're going to keep 3 of these. And when I hit the space bar, these will go into the deselected category, and the ones that I've selected will go into the selected category. So I'm going to hit the space bar. And now you see the selected individuals is 3, and the deselected is 6, and we have another 9 images to go through. So at this point, I'm just trying to cull out the worst ones. So this one doesn't look very good, and the rest I'm going to keep, because I'm just trying to get rid of the worst ones. Okay, so here I'm going to get rid of this one. It's just too fuzzy, not enough detail. And the rest I'll keep. And we keep going through this process. So what we're doing is we're just culling out the worst ones. We're not really doing any evolution yet. What we're doing is we're sort of cheating and seeding the original population with good individuals. We can get rid of this one, this one, this one, this one, and this one, and these four I'm going to keep in the population. Now if you notice, we have down here 15 that are deselected. So those are the ones that we rejected. And what we're going to do is we're going to randomize the deselected. So this little RD button here, I'll just click that, and now it's taken these 15 that are deselected and it's moved them over here into rendering. So it's redrawing those. Anyway, we can keep working. This one's a bit too fuzzy. And like I say, I'm only trying to get rid of the worst ones here. This one maybe is marginal. I'll get rid of it. Okay, don't care for that. Don't care for that. And the rest of these might be of some interest. So just getting rid of the worst ones. And this one's a bit too fuzzy. And of course, this is a matter of taste. And this is why this program creates art that I like, because the fitness function is whether or not I like it. So, I don't know, maybe I keep that. Hard to say. Okay, so I'm gonna keep, I get rid of this one. Maybe get rid of that one. Now, we haven't really started evolution yet. Like I said, we're just cheating and sort of seeding the original population with only individuals that we like. Not sure about this one. And by the way, if you right click on an image, you can see it blown up a little bit. So let's take a look. It's kind of interesting, but not that great. So I'll go ahead and get rid of that. And the rest I'm going to keep. Okay, we've got 11 more deselected. So I'm going to say randomize the deselected. And you see it's now the 11 has been moved over to rendering. So they're being redrawn. Again, I just keep working. I'm going to get rid of these. These. I think this one, I mean, it's interesting. Sort of. But not enough. I need a little more detail, or at least that's my opinion. So whoever runs this gets to be the one that decides what they like and what they don't like. I'm going to get rid of these two. This one's a little bit too fuzzy. And the rest kind of interesting. So again, I'm going to get rid of these two. They're too fuzzy. And what I'm going to do is I'm going to go through the rest of the population, get rid of all the ones I don't like. I will keep randomizing them. So now I've got 6 that are deselected. I'll randomize those. And I will pause the video and I will get back to you when I'm done with that step. Okay, so that took about 5 minutes, and right now we can see that this is kind of the state we're in. Um, we've selected 193 that we decided were good out of the 200. And there's 7 more that we can't see because it'll only show it to us 9 at a time. But that's okay. What we're going to do now is click on Save the Population. Now, we there's the original interface for this. I've actually simplified the interface here, but there's a few functions that I still need to do in the old interface. So what I can do, the old interface was command based, so I can say change status of selected to ready, and that'll let us go on with the next step in the evolutionary process. So now we have 9 that are in selection and 191 that are ready to be worked on, so the images are all set up. Let me put the simple interface back. Okay, so now we're going to start an actual evolutionary process. We are going to be a little more selective about which ones we like. In fact, I'm going to have it default to deselected. So we will just pick the ones we really like. So I like this one. Kind of like this one. And I kind of like this one. And I'm going to be picky, and those are the only 3 I'm going to take out of this batch. And this is similar to what we were doing before, but it's going to be a little different because now we're going to actually do an evolutionary process where we're going to mate the individuals. And let me get a few more selected. Let's see. You know, I pick unusual ones because I'm trying to keep a diverse set of genomes in the population. So this one here, it's not so great, but it has an interesting sky, and some of this. Let's take a quicker look. Some of this is kind of interesting, so I'll go ahead and select that. And while the rest are fine, this one here is fine, I'll go ahead and include that. And the rest of these are okay, but not that interesting, perhaps. Okay, so let's see. Kind of like this one, kind of like this one, kind of like this one. This one is weird. It's like got a yellow tint to it, but like I said, I include the weird ones because I want to keep the population, the genetic diversity within the population, I want to keep it high. This one's kind of interesting. It's got like sort of a silhouette sort of look to it. In any case, we'll keep moving. Okay, this one has some interesting colors and contrasts. This one has interesting colors and contrasts as well. And I'm just going to take those 2. So now if we look down at our status, at the status board, we see that we've selected 16 and we've deselected 20. And now we can have a mating operation. So if I click the little M button up here, then the selected individuals, there's 16 of them, they're going to break off into 8 pairs and each have 2 offspring. And the 2 offspring are going to use the slots that were used by the deselected ones. So let's go ahead and select mating. And now let's look at the status board here. So there were 20 that were deselected, so now there's only 4 that were deselected. There are 16 that have been mated, and they've been put in a separate status group called mated, because even though they might have been good, we don't want to have them oversaturate the population with their genetic material. So anyway, here we go. We continue. I'm getting picky here. Maybe this one's okay. This one has some interesting properties. This one has some interesting properties. Like I say, you're not picking the best ones here. You're picking the ones that you want to have contribute their genes to the population. So I'll say go ahead, we'll throw that one in. It's got a sort of sketchy sort of look to it. And none of these, the rest of these, maybe this one, it's a little weird. Okay, so I like this one. I like this one. Now, at any time in this process, you can decide, oh, I kind of like this, so I think that's kind of interesting as an artwork. Now, you have to realize this is very low resolution. It's only 405 across and 270 pixels down, so it's just sort of a thumbnail. I could say that I want to render it in low resolution, which is 1600 by 1000, and here we're seeing the image created at that higher resolution, and we can just take a closer look at it. And I kind of like the sky. It's got a kind of hatchy sort of pattern to it, and I like the parking lot. It's kind of impressionistic, just a lot of dots of color. That was at the low resolution. I can try it at the medium resolution. This is about 3000 by 2000 pixels, so we can see it. Being drawn. Right now, up here in the corner it says this is like a progress report, so it's 40% done. It draws the larger circles first, so the details will all come in the second half of the drawing. So anyway, it's kind of interesting. I can also do a large resolution. Now this is very high resolution. This is 16,000 by 10,000 pixels, and I use this. This is what I can send to a printer who can print a fairly large large picture that could be framed and hung on the wall. There's no way I can show you the detail in this, because the there are no computer monitors that I know of that will display this type of resolution, but it can be printed. So at 300 dots per inch, it's about 3 feet by 2 feet, um, and they tend to look pretty good. Anyway, I can leave this running in the background, and we can go back to what we were doing. So we were selecting this one, I guess, is okay. Every once in a while, I like to include one that just sort of looks normal, because we want to keep those genes also in the population. Okay, so let's see, which ones do I like here? I guess this is kind of interesting. This one's kind of interesting. This one's a little weird. It's got a reddish sort of tint to it. And then, like I said, I throw some in that don't look too distorted, just to keep them in the population, so that we don't get nothing but weirdness. Well, not that weirdness is a bad thing. Let's see, what do we got here? Guess this one's kind of interesting. This one's kind of interesting. Now notice that we keep right now we've got 15 that are selected. If we do the mating, only 14 of them can be mated, so it still leaves one as selected. And we just keep going. I kind of like this one. In fact, I think I'd like to see what this one looks like. Now, remember we did the small, medium, and large of this last one, which, by the way, we're almost done with the large. It's 75% done in the high resolution. Now it's 80% done. 85. 90 and 95% done. And now it's 100% done, and it's been saved. So I will close this. Now here's a new one. Now if I click the A, that stands for all. It'll do the small, medium, and large. And I can just leave it in the background, and it'll work on it. Which one was that? That was this one down here, right? So I definitely want to select it to keep it in the population. This one's kind of interesting. This one's also kind of interesting. And I think that's it. Now, this is all a question of taste, so whoever runs the program gets to decide what it is they like. So there's 3 individuals. I think that's enough from that group. Kind of like this one. And this one. And this one. And maybe this one. Yeah. And this one, it just seems too yellow, too heavy a tint. Now, with all this work going on, the computer can get a little slowed down. It's probably an excuse for me to go get a new computer. But this one is working, even though it's a little slow at times. Here it's doing the high resolution one. Well, we'll wait till it's picked it up a little and we'll go watch it do that. Okay, so here's kind of like this one, kind of like this one. This one's a little weird. It's got a sort of purpley tint. I'll go ahead and select those. Let's jump over here and watch this individual artist do its painting. And remember, it does the areas with least detail first, and then it fills in the detail afterwards. So right now it's 35% done, and we're starting to see the image of the cathedral. Kind of like that sky. You know, this was a technique of the Impressionists, was to create colors by creating dots of many different colors that would then blend within the viewer's eye to create a color that anyway, here we are, 85%, 90%. It's just putting in the last details, and now it's all done. And if I had because I picked the all, it'll close this by itself. So it's really intended to be run to run unsupervised. And let's see, what do we like here? This one's kind of cool. This one's kind of cool. I kind of like that one. I think that's it for these. Now we've got 17 selected, and there's no rendering going on, so let's keep the computer working by click mate, so the selected ones will pair up and have offspring. Here we go. Now this one's kind of cool, and I kind of like this one. This one's marginal, but I'll go ahead and take it. And here we go. This one's a little weird, but I like it. This one and this one, and oh, kind of like this one. I'm even tempted to maybe render it. Yeah, I'd call that art. So I'm going to click the A so that it'll run unsupervised and create all three of the resolutions. This one has that yellow tint, but I still kind of like it. It's like almost like a sunrise sort of look. This one has some interesting pinks. And this one, a little unusual. It's got a similar sky to this one. Oh, let me make sure I select that. And I'll go ahead and select that. Just, I want to have a lot of diversity in a lot of genetic diversity in the population. So I'm going to take this one And now this one's fuzzy, but somehow I like it. Let me just take a closer look. Yeah, I like that. I'm not going to generate an artwork out of it, but I am going to keep it in the population. This one's unusual, and I like the contrasts and colors in that one. Okay, so again, I'm going to pause this because what I'm going to do is I'm going to go, I still have 75 more images to go through and pick which ones I like. I will go ahead and mate all the ones that I like, so they'll be over here in the mated section. And all the ones that are left over and deselected and are not used as slots for the offspring of the mating, I'm going to randomize, and then I'm going to save that population. Let's take a look at this as it's being drawn in the high resolution. So it's 10% done. Like I say, puts the details in last. The way an artist would do, right? Because you rough out the sketch and put in some background colors and things, and then start adding the details. It's 50% done, but it's the last 50% that is the sort of adds the details. I like the sky. I mean, it's a little wild, but certainly colorful. Okay, so that's done. It's going to close it on its own because, like I said, it's supposed to run unsupervised. I am going to again pause this picture while I go through the selection of the remaining individuals and mate all the ones that I've selected, and then any leftover deselected ones I'm going to randomize, and then we'll save that population. It's always good to include some randomized individuals to keep genetic diversity in the population. This has been my research area, is evolutionary computation, where you evolve populations of solutions to problems. Not always, or usually not art, although evolutionary art is a field. Usually it's problems that can be solved. Sometimes financial problems, trying to evolve resilient portfolio allocations that are resilient to different types of events, and also to evolve trading systems. But that's another subject for another time. Anyway, I'm going to pause this and I'm going to complete the select. Okay, we're back, and I've been working on this thing, and what happened was I've mated 132 of the individuals. There were 60 some individuals left over, and so I randomized them and threw them back in the population. It's always good to have like an influx of random genomes into the population. Um, Also, I'm rendering an individual that's kind of blurry, and I'm going to show you. I'm going to show you what I can do with that later. There's like a post-processing that I do sometimes with the images, and I'll take a fuzzier image and put it as a layer behind a more detailed image, and it creates an effect. You can adjust the transparency of the different layers, so you can add some interesting things to a final artwork. This is if I'm not mistaken, one of those fuzzier images that I might use as a background layer um, to include with a more detailed image. Gives um, a sort of a nuanced. Anyway, it's all art, right? And here we are. We are done. Um, all of these are ready. Let me go back to my two interfaces. It's kind of weird, a program with two interfaces, but I'm going to save this population, and I'm going to go over to the other interface, and it's reported that the population was saved. And I am going to change status. This is probably something I need to add to the other interface. Seems to be all that I have made it. To ready. So now they're all ready. Oh, there's one that was already selected. I changed selected to ready as well. I like these command line interfaces. So I've been writing all my software with it. And it doesn't preclude a more user-friendly interface. So, for example, if I have the command line interface up and I'm over here, now I can click mated, but there are no selected or deselected individuals, so it shouldn't do anything. But it reports, it actually runs it by running the make command through the command interface. So, which is kind of cool. It allows you to keep a history and actually create a batch file that you could repeat all the things you did previously without having to click around and repeat all the mouse clicks. Okay, so now it's just rinse, lather, and repeat. We've made 3 generations so far. The first one was just the random individuals. The second generation we did by selecting out all the ones we didn't like from the random individuals. Then the third population was made by mating the ones that we liked. And so now we're seeing the results of that. So these are this is the beginning of an evolutionary process. I remember this, kind of like that. And tend to get a little pickier over each generation. We now sort of have a higher standard of what we're going to allow to survive into the next population. Also, you got to do this sort of quick. You don't think too much about it. Just go with your instincts. Every once in a while, you'll accidentally include something that's not that great, and you may exclude something that is great. But that's the way evolution works. You can be the strongest wolf with the best eyesight and the best claws and the best teeth, and just by bad luck you're on the top of the mountain when the lightning hits, and that's the way evolution works. It's certainly, I won't say a random process, but I'd say a stochastic process. Okay, here we go. Keep going. And remember, at any time in the process, if you see something you really like, then the last stage of the workflow is to turn it into an artwork. So okay, I think I double hit the spacebar, which killed off random 9 individuals. But that's the way evolution works. Tough break. You never know. You can eat healthy, and then you're on a bus and the bus crashes, and that's life and death. Anyway, I don't want to get too philosophical here. We stick to what we're doing. You tend to go fast, and you just use your gut instinct. You like it or you don't like it. It's unusual. You're going to keep it, not keep it. It's all stochastic. One thing you can sort of do is, if you see stuff that you've selected before, or it's very similar to something you've selected before, you might exclude it, because you don't want the population to become saturated with some genes. Okay, so this one is an example. I've included that many times, so I'm going to leave it out and pick some different ones. The other thing is, if you see something's a little strange, it may not be, what you'd think of as a great artwork, but if it's unusual, you might want to include those genes in the population. And this, like here's one that's a little unusual, but I'm going to throw it into the population. Here's some others. Okay, so at this point, I've got 81 that are selected, 99 are deselected. I'm going to go ahead and mate the population. So we can see that we're now down to 1 selected, 19 unselected, because all those individuals have been moved over to mated, and their offspring is in the queue to be evaluated. So that's how evolution works. The ones with the higher fitness functions survive and mate, and then that same test, that same fitness function is applied to the offspring. And this is repeated generation after generation. And this is what makes up evolution. And there are people who don't believe in evolution for some reason. Maybe it conflicts with their religious views or something. So you don't have to think of it as evolution. You can think of it as breeding. So, you know, humans have been breeding animals for a long time, and what they do is they select the ones that have the traits that they like, and they keep those and mate them, and the ones they don't like end up as barbecue. I'm a vegetarian, so not a big fan of barbecue, unless maybe barbecued tofu. It actually tastes really good depending how it's prepared. I mean, has almost no taste, but you have to do things to it. But that's for another video. I'll do a cooking video eventually. And we're running a little low, so I'll go ahead and mate the population. So now I see everybody on YouTube is begging for people to like and subscribe and leave comments. I really don't care. I'm making this video more so that I remember how to work this program like 2 years from now. It's easier to make a video like this than to write an instruction booklet. But if you have any ideas for how I could improve this program, feel free to comment. I know this has been a long video, and I appreciate anyone that's been here this long. Now, this is interesting. I think I'll go ahead and make an artwork out of that. Kind of impressionist abstract. Techno abstract impressionism. You gotta have some bullshit when you go to the gallery. Okay. I had some works in a gallery, and this was in Palm Beach County. This Same where Trump has his little country club that he never invited me to. And I think I sold one or two pieces, but there was the art editor from the local paper and came and asked me how I made these pictures. And I explained the whole thing to him, about evolution and all this stuff. And at the end he goes, yeah, but how did you make the pictures? And then the lady that ran the gallery came up to me afterwards and said, nah, don't explain anything. It's too complicated. And the guy never said anything about my work in the papers. So let's see. I think we're done. We can do another mating. And then we can take the leftover deselected ones and randomize them. I end up automating all this so you don't have to. It'll look at the status bar and decide when you should mate and when you should randomize the deselected one. Yeah, I kind of like that. It's different. Anyways, as soon as these last ones are rendered, I'm going to save another population. And this is how evolution works. Now we're only at 4 generations. Now this is interesting because sometimes evolution for some problems I can run it for like 100 generations with large populations, but in that case the fitness function has to be automated. So this falls in the category of supervised learning. So it's actually learning to do better art, but it's supervised because I have to keep telling it what's good and what's not. And that can be a bit tedious. And so eventually, I'm just lucky. This thing seems to converge on some nice artwork within a few generations. Because otherwise it just becomes too tedious to have to do all the supervision, telling the system this is good, this is not good. Although that is the process where you as a human being are actually contributing to the art. But I think this video has probably gone on long enough. I'm going to wait till the rendering is done. And in fact, I may not even wait till the rendering is done. Let's go take a look. If we go look in the directory, the Monet 25 data, and this is artworks, and let's look at the medium because the large ones you can't see the detail here anyway. And so let's go Cathedral in Mexico City, and let's take a look and see what we've got. So from this we've gleaned out 5 artworks. Let's take a look. Actually, let me run this full screen. So open with photos, and then I'll maximize this. Okay, so here's some of the artwork that we've created from that picture of a cathedral. We've already talked about this a little bit. I like the what looks like brush strokes in the sky, and also the pointillism below the cathedral. Okay, this one has some interesting color to it. This one it's got some really abstract sky and a little bit of pointillism everywhere. Okay, so this one I like, but like I said, I was going to use this in a post-processing, maybe with one of these other images. And okay, so the video's already gone on so long, I might as well, let me just, let me go to the large Cathedral, Mexico City. Oh, I'm in the medium still. I have to go large. And now I go Cathedral, Mexico City. Sort these. It's only 4. I guess this last image is still being drawn. It's almost done. I kind of like this thing. So it's like the sky is done in a style, abstract art from the mid-20th century, maybe, sort of. And then the ground is done, and the cathedral too, although we can't really see the detail of it, but the cathedral also done in a sort of Impressionist style. So I don't know, it's an interesting, I think I'm gonna use this one with some post-processing, and I'm going to use paint.net, which is that's a pretty cool program. It's not perfect, but I like it. And okay, so everything's done. There's 0 unrendered and 0 being rendered. So I will go ahead and save this population, because I put a fair amount of work into that. Check the other interface. Yes, the population was saved. And I'm going to close this. And now I've got, what, 6 JPEGs here? I'm going to open them all in paint.net. I think I'm going to open it. I think paint.net will allow me to open multiple. I think I can just say open. It'll all go into paint.net. Okay, so I already had a bunch of crap in here. 1, 2, 3, 4, 5. So this is the last 5. I will get rid of all the rest of this, just so that I don't get too disorganized. Okay. Okay, so let me show you some post-processing you can do. So I'm going to say select all and copy. Now I'm going to open this one. It's a little slow. Good. Okay, and now I'm going to say edit, paste into new layer. Okay, so now I put this layer on top, but now I can add properties to this layer of how transparent I want it to be, or the opacity. So maybe less opacity. I'll go more with this one. Okay, and I'll say okay. And I'm not sure. I'll go ahead and merge that down. So now the layers are merged together. And I can do any kind of adjustments I want. Play around with the hues and saturation. Um, this is kind of interesting. I'm not sure that pink goes with the yellow. Yeah, I'm not sure. Maybe I was better off just leaving it alone. Um, Let me try that. I'll bump the saturation way up. A lot of times, it actually looks better if you take the saturation down. So, in any case, I'm not sure I like any of that. Um, Maybe that's the best there with a sort of a blue sky. Not sure I care for it. Okay, so this is interesting. Now look what happens when you zoom in. This is what the image is made up of. Little geometric, and I'll go ahead and I'll go to 100%. So this is what you would see if you walked up to this as a sort of detailed painting. You'd see that the details were created with all these sort of weird strokes. This is kind of interesting right here. I do a little zooming in, and so this is what the image is made of. Now when you zoom back out, well, and that was sort of what the Impressionists did. They used all kinds of strokes. Let's take a look at the ground here. It's probably quite the colorful combination of things. But when you zoom out, all those different colors sort of blend in the eye and create an image there. Now one effect that I like to use is relief. Let me zoom in before I do that. So let's just go here to the side of the cathedral. And we can see all these different strokes. And then I'll do an effect, and I'll stylize, and I'll do a relief. And this makes the image very textured. So when people see this, they then want to like feel it. They've got new ultraviolet resin printers that'll actually put this on there as a texture. Need to see if anybody has one of those that I could play with. In any case, when you zoom out, it's still the sort of the same image, but then when you zoom in, let me pick this area right here. If you zoom in, it's got some texture to it. Well, in any case, that's what I'm up to. I know this was a long video. Thank you for watching. Like and subscribe if you feel like it. If you don't bother. If you have any comments or suggestions, maybe your comment is that my video's too long. Like, that's fine. Leave me a comment. Let me know that my video was too long. I'm going to close all this without saving anything. Maybe I should save this one. Which one is this? This one? I will save this, but I will save it, file, save as, same name. I'll just put paint here, knowing that I did a little post-processing in the paint.net. By the way, it's a great program. Not a sponsor, but still a great program. I got plenty of space. I'll go ahead and use the highest resolutions. Anyway, guys, I've got a Substack somewhere. I think Dr. Tom's Art or something. This one I'm not going to save. And paint.net's going to install and update. That's fine. Guys, thank you very much, and have a super day. And I might see you later, and you might see me later. Bye-bye.